Multiplication with dots and boxes. Let's take a look at a few examples in base 5. In base 5, remember, we use the digits 0 through 4, and each of the 5 dots will make one dot to the left. So the problem I want to take a look at first is the number 40231 base 5. I want to multiply that by 3 base 5. So rather than using what we call the standard algorithm where you would stack the numbers, I want to just think about what's going on with multiplication. And multiplication, one of the elementary things we could think about is repeated addition or repeated sets. In this case, I want to think about the number 40231 3 times. So what I'm going to do is build that number in the boxes 3 times. Let's get started. I'll build the first set with a blue pin, 40231. 4, 0, 2, 3, and 1. Just to illustrate what's going on, I'll build the next 40231 with a red pin, 4, 0, 2, 3, and 1. And the last one with my black pin, 4, 0, 2, 3, 1. Now we have to do some things though to really get the number as a base 5 number. We wouldn't want to say something like, okay, there's 12, 0, 6, 9, 3. That doesn't make sense. So we're going to apply the rule for 5 dots moving to 1. Starting in the ones place, we have 3 dots. That seems fine. We'll leave those 3. In the next place, I can find a group of 5 right there. That will explode and move 1 dot to the left, leaving me with just 4 dots in that space. Moving over to the next place value, I could once again find a group of 5 dots that will explode and move to the left, leaving me with 2 dots. In the next space, there's just 1 dot, so I'll note that. And then lastly, it looks like I can find more than one group of 5. There's a group of 5 that I can explode and move to the left. And once again, there's another group of 5 that I can explode and move to the left, leaving me with 2 dots there and 2 dots in the last place. My final answer would be 2, 2, 1, 2, 4, 3, base 5. So this is just to build an understanding of what we mean by repeated sets or repeated addition. Let's take a look at a secondary example. And in this example, we'll take a look at 2-digit numbers. Let's still stay in base 5 just for purposes of illustration. So in this, I want to multiply the number 342 base 5 times 23 base 5. It's tempting to mispronounce these as 342 or 23, but let's stay away from that. If you see many videos on YouTube, you'll find people doing that. I think it's a big mistake because we don't even really know the values of these numbers too much, like 23 base 5. What exactly is that? Exactly how many is that? We probably have to do some counting or converting. We're just going to stay in base 5 though. So what I want to do is I want to write the number 342 3 times. Now the issue is, how many times is 2 3 times? And so you could waste a lot of time figuring that out. I'm going to go off to the side here for a second to think about that with you. Okay, let's write out the numbers in base 5. 1, 2, 3, 4, 1, 0, 1, 1, 1, 2, 1, 3, 1, 4, 2, 0, 2, 1, 2, 2, 2, 3. And so the number 2, 3 for us in base 5 ends up being the 13th counting number, meaning there's really that many, 2, 3 many with base 5, which is really for us in base 10, 13 many. I don't want to do that. I don't want to draw 13 sets. So let's think about another way to do that. I don't want to draw 342 13 times. So what you do is you appeal to place value. Starting in the ones place, I'm going to look at the 3. Okay, it's 342 3 times. That seems easy enough. Let me do that first. 3, 4, 2. A second time. 3, 4, 2. And lastly, 3, 4, and 2. Let me zoom in just a tad. All right, you can see 3 sets of 3, 4, 2. Now I'm going to look at the fives place. I know it's tempting to call it the tens place or the second place. It's the fives place, right? Well, since I'm over one place value, what I can do is I can think about the number 342 moved over a place value because it's that many times bigger. And then I'm going to do two groups of those. So what I mean by that is I'm going to do two groups of 342, but I'm going to do it here in this place value. And that means that I'm going to use these three boxes instead of the first three boxes because it's shifted over a place value. It'll look something like this. So I'll have 3, 4, 2, and then since I'm doing two sets of those, right, I'm going to do another one, 3, 4, and 2. Lastly, let's apply our base 5 rule, and we should be done. Finding groups of 5 right there. There's a group of 5. We can explode and move one to the left. We have one dot left over. You can see this is pretty hard to keep track of, so we've got to be very careful. In the next line, we have 5 dots there. We have another group of 5 right there. We have another group of 5 right there. That's 3 groups that we can explode. I'll put 3 dots over to the left. And it looks like we just have 2 dots left. We still have 2 dots floating around, so I'll denote that with a 2. Finding groups of 5 again. Let's see. There's a group of 5 there. There's a secondary group right there. There's another group right there. And you can see it looks like I have a perfect 4 sets of 5. So I'm going to put 4 dots to the left, and I'm left with 0 dots there. Looking for groups of 5 here. We have 1 group of 5 and 2 groups of 5. Perfectly 2 groups. That's 2 dots to the left after those explode, leaving me with 0 there. And I forgot to cross some of these out, but it's not necessary. And lastly, I have 2 dots there. Final answer is 20021 base 5. I know what you might be thinking. Surely there's an easier way. There is an easier way. If we're willing to memorize some facts or know some facts about base 5, you're going to see that coming up in a future video.